fifth decimal by 1. I've just kept whatever it was. I was just simply chopping it out. Okay. So you can clearly see that okay, just a second. Just put it on. Yeah. So if you look at it, you will have a round off error. And that round off error will be 2.135472 minus, let's just take a mod because you always do, 0.21355. That is going to be a round off error. And your chop off error is going to be 0.2135472 minus 0.21354. Of course, you can see that they are going to be different. But generally, when we say round off, a computer sometimes may just round it off because that's generally the most elegant way to do. That's what we've been doing all of. But you have to clearly understand here that rounding off and chopping off are two different operations altogether, right? But they have to do with the same thing, that is that it would be based on how many digits a computer can store. Basically the memory space, not the memory space, it is the how much long. So why is there a error in the computer? When you're doing computations using a computer, the error is because of truncation. The error is because of the finite size of the memory elements. The error which is due to the truncation is called as the truncation error, and the error because of chopping off or rounding off, sorry, the error because of the finite size of the memory element, it could be called as round off error. If you're rounding off the value, it could be called as chop off error if you're chopping off the value. So this is basically, we can just categorize it into one, which is called as the round off error. I think somebody has mentioned a comment.
No, sir, it was me, sir. Sir, I was having it out. So, sir, in the present times, there are like supercomputers who are used for big calculations. So, sir, are these supercomputers are made in specific way to to minimize these types of errors?
See, what exactly do you mean by a supercomputer? That is something that you have to understand. See, computer is a computer. At some point of time, it will have the limitation. If what is a supercomputer? A supercomputer, generally, when we talk about it, are basically computers. Number one, of course, they have huge memory and they have huge length of memory units, but they are generally faster. That is what we mean by supercomputer. When we say this computer is a supercomputer, that means it is computing something which is in a very small period of time. That's a different thing. But these are errors which are coming into picture because of certain inherent limitations that any computer will have. Of course, if you take, suppose, a supercomputer or a laptop that you use, then of course the limitation that your laptop have will no longer be a limitation in a supercomputer because it will have a much better memory capacity. It will have series of it because you don't know what e to the power 1 is, and you just write a code and say I'm just including 5 terms, then you will land up with the value that you will land up by doing it with hand. So even if you're doing it with supercomputer, you will have that same truncation error that you will have in your laptop, or you'll have it if you're doing it with your hand. So truncation error is caused because of the fact that you're truncating a series up to a certain number of what do you call terms. So there will be a truncation error. If it's an inbuilt function, then of course in a supercomputer you would be able to store far many number of terms that you would be able to store in error. It's not going to be that much. But even a supercomputer, as you say, a supercomputer will not be able to store infinite number of terms. So of course there will be an error. So of course the answer to your question is that yes, the errors in a supercomputer are not going to be as big as the errors that you would probably see in a laptop. But then you don't really need to worry about all that, right? Generally, supercomputers are used for faster calculations rather than storing large numbers. Of course, you can store large numbers, do large calculations, but the basic essence of it is that you are doing it faster, basically. Right? And that has got nothing to do with truncation error or rounding off or chopping off. I hope I
Okay, sir.
answered your
Thank
question. Yeah. Okay, so so then just to summarize whatever we've done, there are two kinds of errors. There is one truncation error, there is one called rounding error. In rounding error, unless or until I say round off, you will not round off. Unless or until I say chop off, you will not chop off. So in a problem, I may ask you what is the round off error. So then I'll say what is the round off error if you round off the value to 5 decimal. I'll say what is the round off error if you chop off the value to 5 decimal. So you have to keep in mind what I'm writing and what are you being asked. So that is important in a problem which you come in the exam. So rounding off error is not the same as chopping. Okay. So this was the discussion I wanted to have about why there are errors in computer, and this is important for you to know. And the problem with errors is that generally the errors, we don't want the errors to pile up and become a significant value. So long as they remain a small value, we are okay with it. Let them be. We don't really care if the error is of if this is the error, right? If this is the error in our calculation finally, I think we'll be fairly happy to say that the error is of an order of 10 to the power minus 5 के बाद में चाहे हमें कोई मतलब नहीं होने दो इसको. But but if suppose your errors get piled up, and I'll give you a very simple example of it, right? And this is something that you've done in your class 12th also. Suppose you have a quantity x and you have a quantity y, and if I'm adding these two quantities, I'll get x plus y, which is z, right? But if suppose there is a quantity x which has some error, so we used to say that x is x plus minus del x, and we say that y is y plus minus del y. And if I'm adding them, then it becomes x plus y plus minus del x plus del y. This is something that you've done in your class 12, right? And this would be z plus minus del z. So this is the true value here, okay? But this is the error now when you are adding the two numbers. So when you have an error in x and you have an error in y, and if these errors are significant, then when you add them, they will become even more significant. So whatever value of z you will evaluate, there is a fair chance and fair chance that, not far, but fair chance that this z will deviate from the true value, because then the error would be a large value. So if z is supposed to be some value, say 1.2, and this error is 0.8, so there is a fair chance that you're not going to be at 1.2, you're going to be at a value which is far different from 1.2. So the idea is, how can we avoid it? The answer is we cannot avoid it, right? Because if there is an error in x and there's an error in y, the errors will get added, right? Because if you're adding two numbers with errors, this will definitely happen. You cannot avoid this. But if this is sufficiently small, and if this is sufficiently small, then even if you add them, the result should be sufficiently to the power minus 6, 10 to the power minus 7. Even if they get added, it doesn't really make much of a difference, because then the addition is also a very small number. So this is something very important when you write codes. So the reason why you will not converge to a value but diverge to a value is because your errors are adding up and you're going far away from what it should come to. Okay? As I said in the previous lecture, one of the things that a numerical method algorithm should do is it should converge to a certain value. But if it is not converging to a certain value, and it is just diverging or remaining same at one value, not remaining same, but it is diverging, that means that the error is piling up and it is taking away from something. We don't want that in a program. So this is something very important. Errors are very important when you run anything on a computer, and you should be able to track it. And to track it, you should know what kind of errors are there and how can you quantify them, right? So this round of error that we are calculating, this is basically quantifying it, where we know how to evaluate this error. Chop off error, we know how to evaluate this error. So this is important. We need to know this. Okay. So this was a discussion that I wanted to have today. There is another discussion that I want to have today, and that is called as precision. We say that a device is of a high precision. We say that a device is of a poor precision. What do we mean by that? Okay, and that discussion follows from whatever we have done so far. So I'll just continue with it. Suppose I say, that I have this hypothetical computer that can store only 5 digits after decimal. So it can store only this. I should not write 0. Just a second. Let's say that the computer that we have can store something like this: XX, XX, X. Okay? It can store a number in this format. Okay, so I say I have a number, say 0.21534. Okay, then I have a number which is 0.215341. I have 0.215342. Suppose I have 0.1215343, and this continues and it goes to 0.215349, and then I get 0.21535, right? Now my question is, if you have a system, if you have a computer that can store only numbers in this format, then out of all these numbers that I have written over here, what all numbers can your computer store? Tell me. Forget about rounding off, chopping off, whatever. What will your computer store? Look, when you come to this number, what will your computer store? It will store this number only. So this can be stored. If you come to this, what will your computer store? The computer will store 21534, and then can this computer store 1? It cannot store this one because it can only take 5 after decimal. So what it will do, it will just chop it off to 4, or maybe it will try to round it off to 4. But you cannot store this. You cannot store this. You cannot store this value. But yes, you can store this value. So that means that any number between 0.21534 and between 0.21535 cannot be stored in a computer. That means your computer has precision only up to 5 decimal places. It does not have a precision more than that. Suppose I have this number 0.215347127, something like this, and I say store it in this computer, but you can only store this part. The rest will be gone, and that will be error. That information is lost completely. So this is what is called as precision. Precision has to do with the number of decimals that you can store, right? When you say a device is a high precision device, suppose everybody has seen a thermometer in the house, right? A digital thermometer, when you see, we put it under our tongue and we just want to measure the temperature. So it gives us some temperature, 100.2, 100.18. And you can see a small screen over there that has how many decimals? 100.1, char decimal. It can show 100.2. Have you ever seen a temperature called 100.15? Has it ever happened to you? Have you seen a temperature called 100.15? Maybe if your device has high precision, you'll be able to see it, but generally it isn't. It always goes by 0.1 decimal. 100, 101, 102, 101.5, 101.6. It doesn't go like 101.67. It doesn't go like 101.68. You cannot go. So that is the precision of the device. It cannot show those values even if they are. So what it will do, it will just chop off or it will round off and it will give you some answer. So generally for good calculations, we obviously need device with high precision. When we say we need device with high precision, what we actually mean is that we need a device which can store more number of bits. before the decimal and even after the decimal. That is why a 64-bit system is much better than a 32-bit system, or maybe a 128-bit system will be much better than a 64-bit system. Errors, and what are those errors? So we looked into truncation error, we looked into rounding of error. And rounding of error, of course, happens because of what I called as finite precision. But I also wanted to explain what do we actually mean by precision. So by precision, we mean the number of decimal digits that can be stored on a computer. And with this example, I hope that it is amply clear by what we mean by precision now, right? So the idea is we want high precision. That means we want high number of bits to store any value, right? In the next class, we look into what is basically the representation with which a computer stores numbers. So we look into a hypothetical floating point decimal system. We look into a floating point binary system. So binary system is the system in which the computer will store numbers. But we'll do some discussion on it. So the next class will be completely devoted to floating point representation of numbers on a computer, because that is how a computer stores your numbers. Okay, so we'll look into that, and then just a small discussion on different techniques that we'll be using in numerical methods, and that will be the end of unit 1. Okay, so that's it. I'll see you next week. Discussion tomorrow, there will definitely be a new timetable that has to come, because now we'll have classes assigned to computer science and to electronics separately. But then there are some courses that have lectures together, like numerical methods. We will be sitting, all of you will be together. Even in signal and system, you'll be together, and in professional ethics. So those classes are going to happen at a different location, whereas the other classes, which are completely devoted to electronics and computer science, will happen differently. So that kind of segregation is there. The classes which will happen together will happen in our engineering lecture complex, which is behind the management school. I don't know how many people have seen it, but once you come, you'll be able to see it. My office is also there, so I'll be always available there only. The other, we have one classroom in our building where you had come for any physical verification. So there is a room behind that will be allocated to maybe computer science or electronics. Let's see. But yes, of course, we'll have timetables which will now change. So when you come over here, it could just happen that because everybody is busy, it could take maybe a day or two for things to settle down. Because whenever something new happens, there is a transition. So just be a little patient, and things will happen smoothly if we all are patient and we give time for things to settle down. But we are ready to host you here now, and in fact, it's high time that we see each other physically. I have only seen your senior most batch physically for 1 month. उसके बाद कभी किसी को face to face देखा ही नहीं. So I'm really looking forward to meeting all of you and studying in the offline. चलो, okay? Bye bye. See you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank